It's time to turn text to numeric columns. We want to use text columns when appropriate. We just need to convert them to numeric columns, in particular for machine learning. So, why change text values? And again, we're talking about data frames here. Well, machine learning models need numbers as input. That is the primary reason. Next week is going to be focused exclusively on machine learning. So we need to make those conversions in order for the machine learning models to work. In effect, machine learning models are kind of like mathematical algorithms, but good news, you don't have to do the equations. The algorithms do them for you. You just need to know how to invoke them. Also, text is ambiguous while numbers are precise. Okay. Let's take a look at a text column. Here we go. And this is a column titled book. And you can see 3 different types of books underneath: ebook, print, and audio. Now, conceivably, this could be many lines of, or many rows, but the only options would be ebook, print, and audio. Okay, so what is an ordinal column? Well, ordinal means ordered in effect. So the book column may be converted to numeric values as follows, with a certain kind of an order. So we've got the books, and then we're going to give each one a value. So if we start with ebook as 0, it makes sense then to try print as 1, audio as 2. And again, on down the list, whenever we would see another one, like another print, we'd always put 1. Okay. There is an issue with this approach. Can you spot it? A little tricky if you're not really trained to think in terms of machine learning algorithms, but there is something here. Two is closer to 1 than 0, right? I mean, that's clear. But is an audiobook closer to a print book than an ebook? Let's try to reorganize the values maybe to make it better. So what if we start with maybe print is 0, and then maybe ebook is closer as a 1, and then an audio is 2. Okay. This is really better. See, it becomes subjective, and I think that's what we don't want. Okay, we don't want subjectivity. Okay, ordinal column, by the way, that would not be subjective would be like grades, A, B, C, D, F. Clearly, those are ordered, and an A is closer to a B than a C, right? That's unambiguous. But in this case, this is more like interpretation. So what we need is an alternative approach. And it's called one-hot encoding, where 1 indicates presence and 0 indicates absence. For instance, let's say we have the same book column, and then we want to label the ebook 1. Why? Well, because 1 indicates presence, okay? So we've got this new ebook column, and we're giving a value of 1 to the ebook, right? Because it's there. Similarly, an ebook is not a print book, so it would have a 0 there. And it's not an audio book, so it would have a 0 there. Okay? So basically, the ebook column, the first row, it is an ebook, so it's a 1, and all the other rows are 0. Okay, now think about the print column. Where should the 1s and 0s go for the print column? Well, where is print 1? How about the second row, right? That second row is a print book. So it should have a 1 there, whereas the others are not. And so we have 0s in the other rows. And finally, if you want to look at the audio column, okay, can you do this one on your own? Where should we have the 0s and 1s? Take a moment, think about it, and hopefully you did something like that, right? You can only have 1 1 in each row here. Okay, there could be other columns with other values, but as far as ebook, print, and audio, there should only be 1 1 per row, right? Because each one is unique. So the final result, what does it look like? It's a one-hot encoded data frame. Simply put, that's it. The last thing you do is you get rid of the other column. You no longer need the book column. It has been completely transformed into 3 columns, ebook, print, and audio, that captures the same information, but it is now numeric. So this is called hot encoding, big topic in machine learning. This is usually the best method for machine learning. 0 absence and 1 presence have clear numeric meanings. And in Python, you can use, in pandas I should say, df equals pd.getDummies df. Okay, what does that do? Well, it converts all text columns into multiple numeric columns, as you saw in the previous example. Okay, so getDummies is a pandas method that does that, meaning dummy variables here. Okay, and note that when we do it to df, we reassign it to df so that it stays, right? So we're redefining df with using pd getDummies. And that's the approach that we are going to use. Okay, some hot encoding tips. It works exceptionally well when text columns have few options. For instance, a text column with 3 text options will create 3 new columns. However, a text column with 1,000 text options will create 1,000 new columns. What do you guys think about that? Many text entries is a potential shortcoming. If text column entries are unique, a different approach may be warranted, right? So it's not that these algorithms can't handle 1,000 columns. They actually can. Okay, it's just you don't want to like clutter things unnecessarily. So like, I mean, what if you had like a billion rows and they each had different paragraphs of text? This would not be the best approach. You would want different types of approaches there, which we're not going to get into. Okay, we're focused on numeric columns, and we're welcoming text columns that can be easily transformed using pd.getDummies. It's a great technique, and we're going to do it right now in Colab Notebooks.